Most programming languages, including Shell or Bash, which are typically what you're using at command line, provide looping functionality that allows you to iteratively perform some process for a set of variables that you define. While there are a few different types of loops, for loops are probably the most widely utilized and are what we'll focus on here. If you want to follow along, you'll need a couple items in your working directory. First, you'll need the 5 example input data files that are available from the Google Drive link pasted in a comment pinned to this video. In that same comment, I also put a download link for Bowtie 2 and a few instructions for downloading that and organizing your working directory so the code will work as I presented. We'll look at an example where we have 5 different FASTQ formatted data files from high throughput sequencing runs, and we want to align each of these to a reference genome with Bowtie 2. Here we see the 5 data files. Notice the format of the names is standardized, with files differentiated from each other by numbers at the end of the names. We'll take advantage of that pattern in the loop that we'll write shortly. But before we get to that, let's think about what the workflow might be without using a loop. One option for doing these 5 alignments is to simply run each separately, one after the other. For example, the command to do the alignment for the first sample might look like this, where the reference genome I'm using, which is designated with a -x argument, is named lambda virus, and is stored in a folder named ref. The input file, the first of my 5 sequence files, is designated as the -u argument, and the -s argument allows us to give a name to the SAM formatted output file. So I can run this, and once I do, checking my directory contents, I see the output file that was created. I could then run a similar command, but update it by replacing the 1s in the input and output file names with 2s this time, and I could repeat that process to run all 5. Using a for loop allows you to do the same thing, but in a more efficient way. In this case, by iterating over the values 1 through 5 and substituting those values into a variable that's included in the command line command, causing that command to be run 5 times in sequence. Different programming languages have different syntax for constructing loops. In Bash, a for loop has what we'll call for, do, done structure. The for part defines the values that will be looped over. The do part is what will be executed for each value, and the done just defines the end of the loop. So, on the first line, we'll start with for, define the variable we'll use. In this case, I'll use a lowercase I, and then specify the values the loop will iterate over. Here, the numbers 1 through 5. But it doesn't have to be numbers. For example, character strings like file or directory names work too. If we hit enter, the computer recognizes that we've started constructing a loop, but the loop isn't complete, so it prompts us for more. I'll type do next to define what we want the loop to do. Again, we get prompted for more after hitting enter, and here's where we'll enter the command, or commands, that we want the loop to execute. We'll use the same command we used previously to run Bowtie 2, with just a couple modifications. Notice for the input file, I've replaced the number in the file name with $, followed by I in curly brackets. This is notation that says to substitute in the value for the current iteration of the loop. I've done a similar thing for the output file name. We can hit enter again, then close the loop with done and run it. Doing so causes the Bowtie 2 command to be run 5 times in succession, once for each of the 5 input files, and we can list the contents of the directory and see the 5 output files that were created. A couple points about notation with the loops. First, if you now hit your up arrow to see your command history, you should see the loop that you just ran, but notice now it's all on one line, and the different chunks of the loop, the for, do, and done parts, are separated from each other by a semicolon. This notation is equivalent to what we ran before. Also, if you intend to loop over a sequence of either numbers or letters, you can provide a range of values instead of giving each one individually. For example, I can replace the 1, 2, 3, 4, and 5 in the previous loop with 1, ... 5 in curly brackets. Likewise, I can use A ... E in curly brackets to define the range of lowercase letters from A to E. There's quite a bit of flexibility in how to construct and execute loops. For example, you can generate nested loops where more than one variable is defined. You can execute multiple commands within a single loop, or you can take advantage of other types of loops aside from for loops, such as while loops. However, the basic loop structure we looked at here should at least give you a good start if you want to take advantage of loops as you work with your data.